Surprising subglacial flood in Greenland, ice blocks upheaved. A remarkable and unexpected phenomenon has been observed in Greenland, where a hidden lake beneath the ice has dramatically surged upward, displacing massive ice blocks and clearing an area nearly double the size of New York's Central Park. This astonishing event, detailed in a study published in the journal Nature Geoscience, challenges our conventional understanding of how water behaves under such extreme conditions. Typically, we think of water flowing downward due to gravity, but in this case, a subglacial flood erupted through thick layers of ice, pushing up enormous blocks comparable in size to 5-story buildings. Winnie Chu, an assistant professor of geophysics at the Georgia Institute of Technology, expressed her astonishment at this occurrence, stating that it requires extremely unique conditions for meltwater to force its way upward from the bedrock beneath the ice sheet. This extraordinary event took place in 2014 near Harder Glacier, located in the remote northern regions of Greenland. Interestingly, this area is so isolated that a flash flood would likely go unnoticed on the ground. It wasn't until a decade later that Mal Macmillan, a professor of Earth observation at Lancaster University in England, and his research team stumbled upon evidence of this flood while analyzing satellite images for signs of subglacial lakes. Understanding these lakes is crucial because they play a significant role in the water cycle and the movement of ice in Greenland. Generally, these lakes form from meltwater that trickles down from the surface, becoming trapped between the ice and the underlying bedrock. Occasionally, they can drain rapidly, sending water flowing between the ice and rock, which can either flow to the ocean or beneath glaciers, effectively lubricating their movement and allowing them to flow more swiftly. However, these subglacial lakes are typically small, making it challenging to accurately incorporate their effects into models of the Greenland ice sheet. Advances in satellite imagery have allowed scientists to identify changes in the ice surface that indicate when a subglacial lake is filling or draining. In their investigation of historical data near Harder Glacier, their research team discovered a 2-square-kilometer section of ice that had collapsed into an 85-meter-deep sinkhole. Upon further examination, they were surprised to find a fracture zone downstream that they had not anticipated. Beyond this fracture zone lay 6 square kilometers of ice that had been completely cleared by the massive flood. The researchers concluded that the collapsed area was indeed a subglacial lake that had drained rapidly. However, about a kilometer downstream, the water encountered an obstruction. Instead of continuing its downward flow, it surged upward, resulting in the upheaval of ice blocks and the formation of crevices, accompanied by an astonishing release of approximately 90 million cubic meters of water, equivalent to the volume of water that cascades over Niagara Falls in just 9 hours. Remarkably, all of this transpired within a mere 10-day period. After this dramatic event, the water drained back beneath the ice sheet, potentially ending up under Harder Glacier. Coincidentally, during the same 10-day time frame, the glacier experienced a significant calving event where a large chunk of ice broke off and fell into the sea. Additionally, the glacier exhibited unusual changes in its flow rate that summer, indicating that the flood likely influenced its dynamics, as reported by the researchers in their recent publication. As Robin Bell, a professor of marine and polar geophysics at Columbia University's Lamont Doherty Earth Observatory, noted, this discovery adds another piece to the intricate puzzle of how large ice formations on our planet function. The pressing question now is how this new information fits into the broader narrative of Greenland's accelerating warming. Macmillan emphasizes the need to investigate whether similar events have occurred in the past, as understanding these dynamics is crucial for predicting future changes in the region. Greenland's ice sheet floods. 90 billion liters of water burst through. 90 billion liters of water punched through Greenland's ice sheet, and nobody noticed. The fracture zone, where vast amounts of water burst through the Greenland ice sheet. CPOM, Lancaster University. In 2014, a buildup of meltwater under Greenland's ice sheet triggered a flood so massive it surged upward through tens of meters of solid ice, fracturing the surface and spilling water into the air. This event marked the first time scientists documented such a phenomenon in Greenland, offering critical insights into how the ice sheet might evolve as it continues to melt into the ocean. https://Greenland is literally rising from the ocean as it loses its fringe of glaciers. This discovery underscores the power of meltwater lurking beneath the ice, revealing how hidden systems can shape the planet's climate. As the ice sheet retreats, these subglacial lakes, once thought to be mere geological oddities, now pose a significant threat to global sea levels. https://www.greenland's ice sheet is losing ice much faster than we thought. Glaciologist Jade Bowling of Lancaster University explains, "Our study shows that subglacial lakes, though recently discovered, remain enigmatic. We still don't fully understand how they evolve or what impact they might have on the ice sheet." Glaciologist Jade Bowling of Lancaster University explains, "Our study shows that subglacial lakes, though recently discovered, remain enigmatic. We still don't fully understand how they evolve or what impact they might have on the ice sheet." The research emphasizes the need to track their drainage patterns and assess how they could destabilize surrounding ice. The research emphasizes the need to track their drainage patterns and assess how they could destabilize surrounding ice. /eurekalert.org/news releases/109258. Related, mysterious dark river may flow for 1,000 kilometers below Greenland, scientists say. https://eurekalert.org/news releases/109258. Greenland's ice sheet, covering over 1.9 miles of frozen land, holds enough water to raise global sea levels by 7.4 meters if it melted entirely. Recent satellite imaging has revealed complex underground ecosystems, including liquid lakes that fluctuate with meltwater, creating water blisters that reveal hidden dynamics. https://map underneath Greenland ice shows sea level rises. The 2014 flood, which caused an 85-meter drop in elevation over 2 square kilometers, demonstrated the sheer force of subglacial water. As water drained from the basin, it left behind fractured ice and towering boulders, erasing thousands of square meters of the surface. This event, initially puzzling, now signals a new era in understanding how meltwater shapes ice sheets. https://rekalert. "We were shocked by the scale of this event," says Bowling. "It wasn't just a minor shift in elevation, it was a sudden release of energy." The researchers concluded that the flood was the result of water escaping from beneath the ice, washing away vast areas. This marks the first time scientists have observed meltwater punching through the ice cleanly, highlighting the urgency of studying these hidden systems. https://itar.org XS/41569. As Greenland continues to lose glaciers at an alarming rate, this discovery serves as a reminder of the delicate balance between ice and climate. Amber Leeson, another Lancaster University glaciologist, notes, "This study taught us that ice sheets are far more responsive to surface melt than we once believed. Understanding their hydrological systems is crucial for predicting future changes." https://eurakalert.org/news releases. The research, published in Nature Geoscience, highlights the importance of satellite observations in tracking these hidden processes. As the world watches Greenland's ice melt, this work offers a glimpse into the unseen forces shaping our planet. What's next? Will this flood signal a new chapter in Earth's climate history? But here's where it gets controversial. While the study confirms the existence of subglacial lakes, some experts argue that their role in accelerating ice loss remains unclear. Should we prioritize monitoring these systems, or is there too much uncertainty to act? And what if the water isn't just a hazard? It's a key to unlocking deeper secrets about Earth's hidden systems. DOI.org/10.1038/S41561-0251746. Unexpected meltwater floods Greenland ice sheet. Imagine a hidden reservoir of water, trapped beneath miles of ice, suddenly bursting forth with such force that it shatters nearly 300 feet of solid ice. This isn't a scene from a sci-fi movie. It's a real event that happened in Greenland in 2014, and it's left scientists both stunned and scrambling for answers. But here's where it gets controversial. Could this be a harbinger of more dramatic changes to come in our rapidly warming world? Let's dive in. In a groundbreaking discovery, researchers uncovered a massive flood beneath the Greenland ice sheet that released a staggering 90 billion liters, 24 billion gallons, of meltwater from a subglacial lake. This event, the first of its kind ever documented in Greenland, punched through the ice with such power that it carved out a crater 279 feet deep and 0.77 square miles wide. To put that into perspective, the volume of water released is roughly equivalent to 9 hours of Niagara Falls peak flow. And this is the part most people miss. The flood didn't just stop there. It fractured a large area of ice downstream, leaving behind towering ice blocks and scarring an area twice the size of New York's Central Park. The study, published in Nature Geoscience on July 30th, sheds light on the complex and still poorly understood dynamics of subglacial lakes. These bodies of liquid water, trapped beneath the ice, are fed by meltwater and can act as hidden reservoirs. But when they release their contents, the consequences can be dramatic. When we first saw this, because it was so unexpected, we thought there was an issue with our data, said Jade Bowling, a glaciologist at Lancaster University and lead author of the study. However, as we dug deeper, it became clear we were witnessing the aftermath of a colossal flood. Greenland's ice sheet, one of only 2 permanent ice sheets on Earth, the other being Antarctica's, is nearly 3 times the size of Texas and loses an estimated 33 million tons of ice every hour. Yet, despite its significance, much remains unknown about how meltwater interacts with the ice sheet. Traditionally, scientists believed meltwater flowed from the surface to the base and then into the ocean. But this event challenges that assumption, revealing a far more dynamic and unpredictable system. Using satellite data from NASA's ICESat, ICESat-2, and Landsat-8, along with the European Space Agency's Sentinel-1, Sentinel-2, and Cryosat-2, the team created 3D models of the flood. These models showed that over just 10 days in July and August 2014, the meltwater lake uphill from the crater released its contents with explosive force. The findings not only defy past expectations about meltwater flow, but also contradict models suggesting the ice sheet's base is frozen solid. What we found has surprised us in many ways, said co-author Amber Leeson, also a glaciologist at Lancaster University. It highlights the need to better understand the ice sheet's complex hydrological system, both now and in the future. Here's the controversial question. As global temperatures rise, could such events become more frequent, accelerating ice loss and contributing to sea level rise? While this study doesn't provide definitive answers, it opens the door to urgent discussions about the future of Greenland's ice sheet and its role in our planet's climate system. What do you think? Could this be a tipping point or just a rare anomaly? Let's debate in the comments below.